What is up, everybody? So this is our second video for rotation. Thinking caps on, though this is not a lot of in-depth stuff, it does take a few steps. So pay attention, stay focused. It's not going to be too long of a video. It's just 3 examples. That's all it is. All right. Now, the previous video on rotation was all about rotating around the point 0, 0. So all we had to do is apply our rules that were given to us for the 90, the 180, or the 270. But once we move the point of rotation, we cannot just apply the rule because the rule accounts for rotating around this point right here, right? But now our center of rotation has moved over there, okay? Now there is a method that the book or other places will show you that is a 3-step process, and it takes a while, okay? I'm going to show you kind of a hack method that I think is understandable and also is much, much, much shorter. Okay, so in this problem right here, we have triangle ABC. I've listed the coordinates for you, -8, 5, -6, 9, -3, 6. Okay, and we're going to rotate 180 degrees around the point -5, 3. And just so we have our rule handy for us, there's the rule for x, y becomes -x, -y for going around 180. Now, what's nice about this is you're actually not even going to look at the points A, B, and C in regards to their coordinates. We're not even going to mess with them, okay? Instead, we focus on the vector distance from our center of rotation to our points. So here's what I mean by that. So let's focus on point A, okay? So if I'm looking at point A, to get from the center of my rotation to point A, I have to move left 3 units and up 2 units. So this vector is left 3 and up 2. Now, in a translation rule, in vector notation, that is -3, 2. Okay? So again, in vector notation, in translation vector notation, that red dotted line is -3, 2. That's representing that translation. Okay? Now, here's where this is the hack. So what we do next is we apply the 180 rule to the vector, okay? So in this 180 rule, it says xy becomes -x, -y. So to get to A prime from our center of rotation, we do a vector of 3, -2. So what we do is we go this vector, we start from our center of rotation, and we translate 3, -2. 1, 2, 3, 1, 2. To this point right here. Now notice that's a 180 rotation, right? So if I draw a line, it should be exactly straight, and hey, it works out just fine, okay? Let's focus on point B now, and we're going to do the same exact thing. So you can go ahead and draw the vector if you want to, if it makes it easier for you. I don't care. But remember, you start with the horizontal movement, and then you count the vertical movement. So I go left 1, and then I go up 1, 2, 3, 4, 5, 6. So that's a -1, 6 vector. Apply the 180 rule to that vector. So B prime is at 1, -6. So that means that's 1 to the right and 6 down. So 1, 1, 2, 3, 4, 5, 6. So that is where B prime should be. And again, we can check it by, we should be able to draw a straight line from B to B prime through our center of rotation. And last but not least, we have point C. So to get to C, again, you can draw that dotted line if you want to. I move 1, 2 to the right, and 1, 2, 3 up. So that means my vector was 2 to the right, 3 up. Apply the 180 rule. C prime, -2, -3. So then for that one, we just go, now it's -2, so that means we're going to go to the left 2 and then down 3. Okay, so left 2 and down 3. So that's where our C prime should be. And again, just double check real quick, should be a straight line. I think we're good. Go ahead and connect them. And you have now just completed a 180-degree rotation around a point other than 0, 0 using like a, there's no name for this, but it's kind of like a vector hack method. Okay? Let's do another one. Same concept, okay? So we're now going to do the 270. There's our 270 rule around the point 2, 1. So let's go ahead and put that point on there. Actually, let's change that up. I don't like the location of that point. It's on the point W. So let's just do the point 1, 1. I'm going to do 1, 1 instead, okay? That point right there, okay? So, again, you're just looking at what's the vector movement. So let's start with W. So to get from there to there, you're not moving, you're moving horizontally 1, but you're not moving vertically at all. So my vector is 1, 0. Now the 270, to get to our W prime, it says we flip-flop and the x becomes negative, so 0, -1. So I go no horizontal movement now, and now I move down 1 spot. Because remember, it's vector movement from the point of rotation. Okay? To get to x, I'm going to the right 2 and up 2. So my vector is 2, 2. Apply the notation to get x prime. So now again, we flip-flop them. So flip-flopping doesn't do anything for 2, 2, but the x becomes negative. So I'm going to move to the right 2 and move down 2. So that is where my x is going to be. Okay? For my y is 1, 2, 3, 4, 5, 6, 1, 2. So to the right 6 and down 2. So that's 6, 2. Y prime is flip-flop them, and the x became negative. So to the right 2 and now down 6. So there's my y prime. And then for my z, I just go 1, 2, 3, 4, 5 to the right. No vertical movement, so that's 5, 0. So for my z prime, flip them, and the x became negative. So that's just down 5. And then connect them. Let's do a quick check. So all of these should make a 90 clockwise rotation. W, W prime, 90, good. X to X prime, 90, good. Y to Y prime, good. Z to Z, perfect right angle right there. Okay? One more, and then we're all done. We'll do another triangle. We'll go 90. Let's change that point again since we just did 1, 1. Let's do the point 90 rotation. Let's go -1, 1. -1, -1, -1. -1, -1. Sorry for people that had the outline for me changing it up. It's not that big of a deal. Okay, so we have our 90 rule now. There it is. So to get to the A vector, we're going 1, 2, 3, 4, 1, 2, 3. So to the right 4 and up 3. So, excuse me, this shouldn't be A prime, that should just be A. So to get to A prime, we flop them, and that Y becomes negative. So 1, 2, 3, 1, 2, 3, 4. To the left 3 and up 4. Okay? B, to get to B, 1, 2, 3, 4, 5, 6, 1, 2. So 6, 2. Kind of hurrying, guys, because they need to like spray some chemical in my room or something. So B prime, flop them, and the Y becomes negative. So left 2 and up 6. And then finally for C, C is 1, 2, 3, 4 to the right 4. And no vertical movement, so it's just 4, 0. So then that means for the flop, 0, 4, and there's no horizontal movement, just up 4, 1, 2, 3, 4. Let's connect them. And let's do a quick check. A to A prime, 90, good. B to B prime, 90, good. C to C prime, 90, good. So like I said, guys, you have to put your thinking cap on a little bit for this one, but hopefully I did a good job explaining it to you. Let me know if you have any questions.